Solve the problem. Two cars leave from Perm, Minnesota and travel in the same direction. One car travels 1 1/3 times as fast as the other. After 3 hours, they are 45 miles apart. What are the speeds of the cars? We've completed step 1, which is reading the problem carefully. In step 2, we define our variables. Let's let x equal the speed of the faster car and y represent the speed of the slower car. And note that we are given rates and times. And let's go ahead and start by writing the equation. Distance is rate times time, or d equal RT. We'll need that in this problem. And in order to get to step 3 in writing our system of equations, let's use a table to organize our information. We're given that the rate of the faster car, we've defined that as x. The rate of the slower car, we've defined as y. We're told that the amount of time that elapses is 3 hours for both. They start at the same time, and the amount of time elapsed is 3 hours for both. According to the equation d equal RT, or distance is rate times time, then the distance that the faster car has traveled is 3x, and the distance that the slower car has traveled then is 3y. Now we've got a complete table. Let's see if we can now formulate a couple of equations to solve for x and y. We're told that the two cars leave and they travel in the same direction, and that one car travels 1 1/3 times as fast as the other. Now x is the faster car, so it is the one that is traveling more than one time. That is 1 1/3 times faster than y. Or we can write that as x is equal to 4/3 y as our first equation. We're also told that after 3 hours, these two cars are 45 miles apart. Now, according to our table, 3x represents the distance that the faster car has traveled. 3y represents the distance that the slower car has traveled. Therefore, this difference, 3x minus 3y, is equal to that difference of 45 miles. So we have our two equations, and I'm going to solve this system in step 4 by using a substitution method. We have x isolated. X is equal to 4/3 y. So let's substitute that value in for x in equation 2. Thus it becomes 3 times 4/3 y minus 3y is equal to 45. 3 times 4/3 is a 4y. Minus 3y is 45, or y is equal to 45. Now that is the speed of the slower car. According to equation number 1, x is equal to 4/3 times 45, and I'm going to write that as a 45 over 1. That was actually equation 1 there. So x is equal to 3 goes into itself once, 45 15 times, multiplying straight across, that's a 60 over 1, or a 60. So we've solved the system. We have found that the rate of the faster car, or the speed of the faster car, is 60 miles per hour, and that the speed of the slower car was our y value, and that's 45 miles per hour. As a quick check, we might notice that 60 is indeed 4/3 times 45. And for equation 2, we can notice that 3 times x, or 60, minus 3 times y, 45, is equal to 45, because that is a 180 minus a 135 is indeed equal to 45. So we can feel pretty comfortable that we indeed have the correct solution and that the speed of the faster car is 60 miles per hour and the speed of the slower car is 45 miles per hour.